Hello everyone, welcome back. So hopefully this half will be a little bit less crazy and hopefully I will look less like I don't know what I am doing. Okay, so what we were talking about before was this idea of having perspective changes that can result with you getting much closer to something and using a very wide angle lens, and the sort of result, the sort of distortion effects that you can get by using a wide angle lens. And how you can try to correct it by trying to square up basically your lens with all of the angles that exist in the room. But there is a different way that you can use, that you can solve this problem as well. And as with most things, you can solve it by spending money. And if you decide to spend money to correct this sort of perspective change that can exist, one of the things you will want to investigate is using or purchasing a tilt shift lens. And so I have to mention right now that these are very expensive lenses, but they can be used to correct perspective changes. And also, like with most things in photography, we can also try to adjust things in Photoshop, or to use software to try to correct some of these geometric distortions that can happen as a result. However, as with most things, software, that takes a little bit of time, takes a little bit of knowledge, and it can be perhaps a little bit prohibitive. So again, you can either spend time or you can spend money to try to solve these issues. Now, talking about lenses, if you remember from that video, they said that there's this one guy that works at this lens factory, and he very painstakingly basically writes the data that exists on the side of a lens barrel using this sort of reducer, this template and reducer mechanism that they seem to have, which is pretty neat. But luckily, at least for many of the modern lenses, we now see that they're printed on. So this poor guy is unfortunately perhaps out of a job, but it also means that this happens a lot more quickly and is a lot less error prone. But one of the things that the video did say is still relevant to us, and that is the data that's imprinted on the side. Usually we will see some sort of focal length indicating the magnification level or the zoom level of this particular lens, and also we will see the F number. And so I suspect that they were trying to make a list of 3 items out of 2, and they actually mentioned 2 different things, the F number and also the size of the aperture, which I guess you could denote from the F number, but that's really not the case all the time. Perhaps what they were talking about was in fact this other thing called a filter size. And so with most lenses, what you get on the front when you actually purchase a lens is a lens cap of some kind. And usually if you take off that lens cap and you look at the inside ring, you'll notice that it's actually threaded like a very large screw. And you can put a number of filters on the front of that lens to modify its behavior in some way. And we'll talk about filters at the end of this lecture. But the size of that thread is denoted on the lens by the filter size. And you'll notice that we have another symbol here that you will unfortunately have to remember, but it is very similar to something else that we've seen before, that vertical line with the circle, which denotes the film plane. But in this case, it's a sort of slanted line. It's more like a null symbol. It's a slanted line with the circle that indicates filter size. And so in this case, we can see that if we purchased a 67mm filter, it would work on this lens. We could screw it on the front and it would work on this lens. And so most lenses, even the ones on compact digital cameras and even the ones on some camera phones, you will find the same sort of data printed on the lens barrel in some form or another, or in some location or another. And so you'll generally see something like this. So in this case, these are just these 2 are Canon lenses that are just used as representative examples, and the one in the upper left-hand corner is a Pentax lens, but it tells us quite a bit about the lens itself. So as we talked about, the focal length. So in each of these cases, they're all zoom lenses because we see a focal length range. So we see the minimum focal length that they're capable of through a maximum focal length that they're capable of. And we also see the maximum F number that these lenses are capable of. So basically the largest diameter at which the aperture is possible to be placed at. And we can see that on this lens it's an f4. This lens here, it's also in f4. You see it says 1:4. Usually you'll see it's a couple of different ways, but it's all represented, it's represented different ways but means the same thing. and over here we have a 1:3.5 to 5.6. Now, each of these things tells us different numbers for the f number, and it's important to remember that this is the maximum size of the aperture, which means it's the lowest f number these lenses are capable of. However, there's something funny going on with these two lenses in particular. And so if we focus on this one for a moment, you see that in parentheses it has the number 22, which probably means, and I think this is pretty rare in lenses nowadays, but I think it means the maximum f number that you can use for this particular lens. So you have a range, basically an f number range of f4 all the way to f22 on this particular lens. Now the one on the right is somewhat different. You see that it says it has an f number range of 3.5 to 5.6. Now keep in mind that this doesn't mean, the 5.6 doesn't mean that that's the smallest the aperture can be or the highest f number. Instead, what this is telling you is the maximum f number range through the zoom range that it's capable of. So at 18 millimeters, at the smallest focal length, it has a maximum f number of 3.5. But as you zoom in with this lens and you get to 55 millimeters, the maximum f number at that focal length is 5.6. And so as you zoom in, it sort of varies. It increases as you zoom in from 3.5 to 5.6. But this lens then is actually relatively slow. If the maximum aperture is at the most telephoto range is 5.6, then that's, I mean, you have several stops available to you, especially when you compare it to, say, this 50 millimeter prime, which is capable of f1.8, has an f number of 1.8 on it. And in fact, this is that lens that I'm always recommending if you're a first-time SLR buyer. You don't want to splurge on very expensive lenses. That's usually a good first one to go with because it has very wide aperture. It has a very low f number for the price and for the weight and for a variety of things, for its size as well. Now, typically you will see a lens that's like this, especially when the lenses are more inexpensive. You will see a range of f numbers that, or the maximum f number varies from within the zoom range. But as you get into the more expensive lenses, you will sometimes see that the maximum aperture actually stabilizes. It remains the same throughout its zoom range. And theoretically speaking, and talking about this, and if money were no object, that's generally what you want. Is you want an f number that's going to remain the same, because then that way it doesn't actually alter your exposure calculations as you change zoom ranges, and it also doesn't affect the brightness of the viewfinder. And now, one of the things that will actually happen when you put a lens on the camera, when you look through its viewfinders, you are actually seeing the image that your camera is going to take. You are literally seeing the image through that particular lens. So if you have a lens that has a larger aperture, it's going to be brighter because it's going to allow more light in, and it's going to therefore allow more light through the viewfinder and to your eyes. So therefore, a lens that has a lower f number, well, a bigger maximum aperture, it's the same thing, remember, is going to be better for you in terms of usability, because you'll be able to see things more clearly. Things will be brighter through the viewfinder. And if you don't believe me, take, for example, this lens here, and then take another lens, like, say, this one, zoom it in all the way to about 55 millimeters, and if you take one off and put the other one on, it will be noticeably brighter or noticeably darker, depending on which one you put on the camera. So it's also a usability thing for you as well, how easily you will be able to take a particular image. Now, keep in mind that as you get to be, as you purchase lenses that have lower f numbers, so maximum apertures, higher maximum apertures, then you're going to be spending a lot more money, and you're also going to have a lot heavier of a lens, because every time you double the area here, that means you're putting a lot more glass, and this glass is really heavy and really expensive into one of these lenses. And so even when you get up to the higher range lenses, you're going to have to make a decision between weight and cost and how much light you want available to you and to your camera. And in fact, if I can keep talking about this stuff, your camera is only capable of autofocus within certain maximum aperture ranges. So if you put a lens that's on your camera, and a typical SLR camera cannot autofocus once you have a lens that's any darker than 5.6, and about an f number of about 5.6. So once you get to a lens that's f8 or f11 or anything above f5.6, your camera loses the ability to autofocus because it's simply too dark for it to be able to perform its autofocus calculations. Now, the only exception to that is, of course, when you get to the really expensive cameras. Then you are able to use lenses that are maybe about f8 or so, but even then, you're not going to be able to go much darker than that. Now, realize that I don't want you to get confused between setting the f number up here and your camera's ability to autofocus. So if you set the f number to something like f11 or f16, your camera is still able to autofocus. The reason is that the aperture is inside the lens is always open at its maximum capability. So when you're looking through the viewfinder, and when the camera is taking its exposure calculations and focusing, it keeps the aperture as large as it possibly can to let in as much light as it possibly can. Then when you set the f number on your camera and you take the photo, very quickly does it stop it down to the proper size. And if you remember when I passed around the camera, you push that button, that's exactly what it does. It stops it down, takes the photo, and then opens it back up again. So just because you set an f number higher than f8 or f11, it doesn't mean that your camera is suddenly going to not be able to autofocus. It's an actual physical limitation of the lens that's going to prevent it from autofocusing. Okay, now as you can gather, changing the focal length will actually alter the size of the lens itself. And as I showed you in that one particular image of that, that monster 1200 millimeter lens from that B&H ad, that is a really huge lens. That is, it has a focal length of 1200 millimeters, and there's very much a correlation between increasing the focal length of a lens and its size. So as you increase the focal length, you will generally have an increase in size as well. So just to give you an example between some of these differences, so from left to right on this list of lenses that I have here, we have a 24 to 70 zoom with maximum aperture of f2.8. Then we have a 70 to 200 f4, then a 70 to 200 2.8. And so you can really tell the difference. Now, yes, it's a little bit longer. It doesn't mean the focal length has changed, but what's more important is the bulk, how much wider this lens actually is. And it's actually considerably heavier. I don't know if it's twice the weight, but it's probably about 1.5 to 2 pounds heavier for this lens on the right. And I can guarantee that if you're walking around with this lens, you're not going to want to carry around such a heavy lens all the time. Just to give you a comparison, this is a 70 to 200 f4, but it's an IS version, so it's just slightly larger than this one perhaps, but it's definitely not as big as this. Okay, so moving on this side, we have, let's see, 70 to 200, so we have this lens, this 70 to 200 f2.8 right here, and then next to it, this behemoth of a lens is a 500 millimeter f4. So you can see that as you get larger in these lenses, you're going to have to break your back to carry them. And one of the things you'll notice is that these larger lenses, not only do they have these plates for you to attach them to the tripod directly, but also they have their own straps so that you carry this camera with the lens attached to your neck, strapped around your neck, and the camera is just dangling around the back. And to give you a more real-life comparison, this lens that I was talking about before is a 300 millimeter prime f4. So this lens it's not capable of any zoom or anything like that. But if you really want to impress your friends, it actually has a built-in lens hood that you can extend. And they say, wow, that's a really big lens. And you're like, yeah, it is. Okay, but anyway, beyond that, you can see the lens hood for this 500 millimeter lens sitting right next to it. It's very, very large, and as you know, the lens hood is used to protect flare from these lenses. And one of the things you might notice about these lenses in particular is that most of them have these red rings around them. This is Canon specific, and it indicates their L line of lenses, which is their upper end, their higher range of lenses, and usually means that it's automatically going to be very, very expensive, and it's automatically going to be, well, there's going to be a lot of snobs online, especially if you look online. There's a lot of snobs that say you have to buy L glass because that's the only thing you can do. It's not necessarily true, I don't think. I think you can get very high quality lenses out of some of the less expensive lenses that exist. But once you reach a certain point, a certain focal length, you usually have no choice other than to purchase these more expensive lenses. Now, one of the things that this red ring does do for you is that it does mean that it's Canon's higher end of equipment, and Nikon has a similar thing. I don't think it's a ring per se, but I think they have I think it's called a G-type or something. I don't really know Nikon's range very well, but basically they have some way of telling you that you are getting perhaps a couple of features that are better than their lower cost brothers. And in particular, you are getting higher autofocus speed, for example. So you will be able to focus much more quickly, or higher build quality, or even what many of these are capable of is a form of weather sealing, so that if you have a weather sealed body, you can actually use it in all but the worst weather, including rain and snow and all sorts of stuff, and be able to use it safely. And I found that in my experience that most of these lenses are capable of a little bit of drizzle, a little bit of rain, and I'm not even talking about the L lenses. I'm talking about even just the regular lenses that you can get. They're pretty well built, unless they're the absolute cheapest you can get. They can handle a little bit of abuse, but the L lenses, there's a number of them that are weather sealed and can do some of this stuff a bit better than just the normal, less expensive lenses. Okay, now in terms of taking the raw photos, having a fast lens is good, and a fast lens, remember, means that you have an f number that is very, very low. And so if you have a lens that is fast, then you're able to open up its aperture a lot, and you're able to get not only a lot of background blur, but you can also get a lot of shutter speed. You can get a very, very fast shutter speed. So you are given more options by having a faster lens. But of course, the downside then is not only the expense, but also the weight. And so you have to make this trade-off between what you want to spend and how much you actually want to carry in your kit. Now, when we're using these fast lenses, we do have quite a bit of background blur behind the subjects. And I really just did a lot of hand waving before and glossed over it and just told you that that was true. But now we get to talk about why that actually happens.